Hi, everybody. Thank you for being here today and listening to my talk. My name is Mark Korver. I'm the geospatial lead on the worldwide public sector solution architecture team. Can everybody hear me okay? Good? Oh, it's not on? Oh, This one?
Yes.
Oh, okay. How's that? Is that better? Okay. I hear echo now. I'm on reverb. So I'm going to give. My name is Mark, and I want to make sure everybody is comfortable coming to me after this because I'm sure I'll miss a whole bunch of stuff. I think Chris is here. He's also a solution architect. He's also on the specialist team. So we have we're going to be doing a birds of feather, this evening, I think, right? At 7. So please come on by. There's a lot of stuff that was talked about in the previous talk that I'm pretty sure we have answers to, right? So happy to help there. I was actually one of those customers at one point. I remember billing about $4,000 or $5,000 a month, and getting a telephone call from somebody from Amazon. I thought I was in trouble because I was routinely firing up lots of machines, and nobody was bothering me. Somebody called me, and I thought, oh, okay, I finally, messed up. I somehow caused trouble, and it was just this friendly call, right? thing. So I know all about. I'm sure we have many customers that are billing at that rate that we're not reaching out enough to, right? So anyway, the reason I'm here, the reason Chris is here, is because we want to make sure that you are all well supported and we're answering questions. So today, as you can see, I'm going to talk about NEXRAD. So we have a number of what we call public data sets that we make available to our customers. Generally, those are public data sets that sit in our object store called S3 Simple Storage Service. NEXRAD is one of them. We also have Landsat 8, and we'll have other satellite-based sensor public data sets coming out in the future. One of the things I wanted to quick announce that just kind of came out today is something we've been working on with folks at a number of places, but Mapzen has been leading this, and there's a new global worldwide elevation data set that's available. And I've got like this box of cards here that I really don't want to take home. So please come up and grab one of these. It's got, so you don't have to take notes. You can go find the data set after the fact, right? So please come and get one of these after my talk. So that's all the time I'll spend on this, but a lot of what you see here and what we're going to be looking at with NEXRAD, I think, are hopefully ideas you can use for data we have up there now, data that you might have or considering putting on our object store. And so I'll be showing what I think is a fairly practical, easy to understand architecture that runs on us, specifically using Docker. I need to change modes here. Docker running on our Elastic Beanstalk service. Now, I got this thing, quite frankly, working like last night finally because I spent way too much time trying to understand the PyArt project, right? Which I don't know anything about radar data, so I spent a whole bunch of time trying to get a Docker image working with all the scientific libraries working to get this new pull request on PyArt actually working in conjunction with GDAL, right? And so it'll be rough, but it'll give you kind of a picture of what it looks like, trying to make something like this work in our environment, the practicalities, and where we help to get you to market faster. Even though like my Python code is very crude and barely works, I can still crank out a bunch of data, right? I'll fix it tomorrow. I got to get to market right now. Okay, so if you do a search for exactly NEXRAD on AWS, you'll see a page like this, and it'll talk about how we have essentially two buckets where we are loading. I'm making assumptions. I didn't know anything about radar data, so NEXRAD is Doppler radar data, and typically you see that as the end result in a map. When the weather person is talking about what the weather looks like today, right? one of the inputs to that, I'm sure there's many that I don't know about, one of the inputs is Doppler radar. We've heard that term before, right? So we have two buckets now. One holds Doppler radar chunks, so this is like within seconds, 160 radar stations are reporting to our object store. And they're putting about, I was just looking at yesterday, so yesterday was about 1.6 million puts to the object store. You all have access to that object store, right? There's another bucket, which is archive bucket, which archives those chunks and puts them in another bucket. So we have an ETL around that. So we actually now have a number of weather companies that have changed, have switched their ETL for this class of data to what they used to be doing with, for example, Unidata before. Now they're just pointing at our S3 bucket because it's easier, faster, simpler, right? So if you look at this page, you'll see reference to where it is, what the bucket names are, and I can show you that in practice over here by switching to this S3 client called Cloudberry, and I'm going to pop over, go to the root of my working account. So on the left-hand side is my working account. Right-hand side is my notebook right now. I could have two different accounts in here. I'll show you how that works in a second. On the left-hand side, you'll see there's a bunch of green-colored icons on the left-hand side, and as you go down, they're blue. The reason they're green is because they're not my S3 buckets. These are buckets that are shared to me, either because they're completely public to the world or because somebody was okay with me looking at it, right? And so if we look, and I got to look carefully here, so here's NOAA NEXRAD level 2, and you can see it's ranged by years, right? We're almost halfway through the year, so let's go look at this month. We just got started this month, and as you drill down here, now you hit 160 Doppler radar stations. These are the key names for that. And if you look in here and look at the timestamps, they should be arriving, within a few minutes of each other. I think it's about 4 or 5 minutes, that kind of thing, right? The chunk data arrives within seconds. This arrives within minutes. There's approximately 30 to 40,000 of these puts to the object store on a daily basis. The chunk data is, like a million plus, right? Small pieces. So today I will be showing you a simple Beanstalk-based method to wrap your Python code. So essentially the idea is I have a little bit of Python code that's leveraging smarter people, right, who wrote all the scientific code that I don't really understand, because I want to not just look at the Doppler radar station near Seattle, my hometown. I want to look at the whole darn thing, right? And I have to admit, what I was hoping to do was show you a beautiful map in real time today, but I didn't quite get that far. That's the next step. I'll show you a map output that's manually provisioned, but I'm almost there. So this is kind of the beginning of being able to do this stuff. So anybody now, by looking at what I have up on GitHub, should be very close to being able to do their own Doppler radar-based weather station, right, with real-time mapping. And I hope to be able to do things like put like a tiling layer on top of that, and so you can deploy it, with CloudFormation script or something, right? So something might not be that interesting to the scientists, but I want to know where the tornadoes are. I have my own weather station kind of thing. That's actually doable now. Okay. So this is what the data looks like. So you can see they're roughly 2.3 megs in size. And so I'll close this. I'll show you the code here. So here's a Docker file. So here's the application. It's a Python script. It's exactly this long, right? And generally what I'm doing here at the top is I'm importing a bunch of stuff. The keyword here for AWS is the Bada library, right? And the main one here that we're leveraging is PyArt, and PyArt recently leveraged GDAL to basically output a geotip file, and it's still a little bit early. It actually uses it goes to the OS to leverage GDAL warp, right? So it's not completely Python native, but it works, right? But this is all it is. So all I'm doing here is fundamentally I have a filter condition, which is just what radar station are we talking about, So if you put a radar station key in here, it'll just look at 1, right, or 2. Here I have star because I want to do all 160, right? And all I'm doing is reading some JSON, grabbing the payload that I'm interested in, which is essentially just where's the file, right? And then having that, you can see down here, I'm making a connection to S3, and then I'm importing that key. I'm copying it to a local file system. And then down here, so you can see that happening here, I'm using temp file, creating a temporary file, and loading it, making it available local. And I'm doing something called grid, which I don't really know what it is. I was just given this, right? And then finally down here, you can see the geotiff, where it uses the IL right grid right geotiff line. It's just one line, right? Having done that, it's kind of like the earlier conversation. I do not want to have to keep these machines spinning or the EBS volumes that back them up spinning. I want to get that derivative product as soon as possible out to S3 where it's not going to go anywhere, right? I want to turn these machines off as soon as I'm finished working on them, right? So that's all I do here is I do my science here, just a few lines of science, right? And then having done the science, I take that output and I pop it over into my own S3 bucket, right? Now it's mine. Right? And that's all it really is, right? I need to add a bunch of environment variables and exception handling and stuff. That's why it doesn't keep working. It kind of works for a while. But it looks like I do get all 160 Doppler radar stations that have data that at least appears to be correct. I'm doing like 136 every time. That means that the other ones are somehow different, right? Yeah. So I've taken a couple of runs. I don't know why yet, but I'll figure that out. So this is the Python code. Now here's the Docker file, and I'm using something called Miniconda, which I didn't really know about like last week, right? Apparently Anaconda is the way a lot of folks in this area of science at least load Python code, right? So I would typically use something like pip or something, but apparently the method here is using Miniconda. I thought I could use something else, but I could never actually get it to work, right? And so this is something on the order of a 3 gig Docker image file, right? So it's got a lot of code that I don't know what it does, but it's on there. So you could, presumably play with it in all kinds of fashion. So this is available on my personal GitHub account. You'll see this Docker file. I have an image up there that I'm leveraging when I fire up Beanstalk also, and you'll see that all here. So I won't go into the details. So the main thing is the code, the Docker file. And here's this Docker run AWS JSON. This is, I think this is proprietary to Beanstalk, where basically I'm saying, the image is here, it's public, so there's no authentication here. I just want to open up port, 5000, and put the logs over here. It's as simple as that, right? This is what I feed. This is essentially what I need to feed to Beanstalk for Beanstalk to do what it needs to do. Okay, so it's very very lightweight. And so I'll get out of Sublime Text here a second, and I'll go over here back to this page. And so you'll see here down at the bottom, it talks about where the data is. So here's the Unidata Level 2 chunks data, the real-time data. And then further down, it speaks to something called subscribing to the NEXRAD data notifications, right? So imagine there's this bucket. It's being fed for you constantly with either chunks or archives. There's 2 of them. And so we have another service called SNS that allows you to do things like trivially go in there, and if something happens, everybody's phones go beep beep, right? Sends a message or sends push messages, whatnot. And we're just leveraging that. So every time an object gets created in one of these 2 buckets, it essentially sends a message to an SNS topic that you can subscribe to, okay? And what that means is that you can do things like, well, I'll show you. Me talking about it is less interesting than just doing it, right? So here are the different ARNs for these topics. Let me see, archive level 2 object. So here's the archive, and I think this is the chunk one here. So I'm going to grab that and copy it. I'm just copying it. I'm going over to our SQS. So this is one of our first three services, our simple query service, SNS. You'll see here I've got a couple of message queues lined up. That 1.6 is 24 hours worth of chunk data off of NEXRAD. So I'm going to create right now, if I can find the button on here. Sorry, I'm having a little screen size problem. There you go. There's the blue button. So I don't think I have one called. I'm creating a queue called test, right? Hopefully I haven't created one of those already. So I just created a queue. Now we need to go look for it. So there's test, the one I just created. I right-click on it, and down at the bottom it says subscribe queue to an SNS topic. So it's not one of yours. If it was one of yours, it'd be in here, right? This is somebody else's SNS topic, so you can just copy, paste, you paste it in here, hit subscribe, and if this actually works, we should, within a second or two, start seeing data coming in. I need to refresh this guy here. So we see there's already what? I can barely see it. 190 something. Oops. So there we go, right? And if you refresh this, you see this number jump up pretty quickly because it's on the order of 1 million plus a day, right? So that's all it took for you to get notification of the streaming data, right? Now it's in your account. And what's nice here is that if you have multiple processes that you want to use against the NEXRAD data, it's trivial to set up a couple of queues, right? Or you could have a team of people setting up multiple queues and not bothering each other, right? That kind of thing. And so now I have a queue, let's see. Oh, so this is the pull request on PyR that speaks specifically to, okay, I got GeoTIFF working. So this is what I'm leveraging, right? That's all. So a few emails back and forth with the three people that are working on this got me started. And over here, let's see, I got Elastic Beanstalk, and I already have this application running. You see it right here in fiery red color. That's because it's in an error state, right? It's because I have, some number of my 10 nodes that I'm running that are already in failure mode. Okay, so it's giving me a bunch of data about how the code that I just uploaded doesn't actually work at scale, but it works well enough to get through 160 Doppler radar stations of data. Okay, so here so before I kind of pop into this and show you how this is configured, I'm going to go to the top and click where it says create new application. So we'll call this Mark Demo Test or something. Go to Next. And what I want to point out is there's two primary modes that Beanstalk will operate in. One is what is probably more familiar to people because most of the implementations of Beanstalk are public-facing websites where people want to have auto-scaling, load balancing, and be able to do like blue-green deployments, running Docker containers or whatever they want to run basically, right? That's probably the predominant use case for Beanstalk. But we also have a lot of customers that hit the button on the bottom here and operate Beanstalk in worker mode. So it's also auto-scaled and load balanced, but you can use this for doing things like processing queues on the back end or processing anything you want, but it's not public-facing, right? It's some back-end worker that you want to create. You see here that you have a lot of options on, what kind of code or Docker container you want to run on this. So right now I'm using just a generic Docker. You can do Docker or multi-Docker, right? And under the hood, this is actually leveraging our Elastic Container Service, which is a whole other service interface that you can go to. This might actually, I would suggest this might actually be a good way to get started with this. I would think it's actually easier to understand, right? Batch processing is a good way to get started. So you have, if you're just doing dev work on this, you could just have one, or you could, go crazy and start with load balancing, auto scaling right off the bat, right? Hit next, and I won't keep going here, but the idea is you can upload use your sample application, upload your own Python code, point it at your Docker container, whatnot, and the Beanstalk service will take care of a lot of stuff, that we call heavy lifting, right? So, making choices around what EC2 type you want to use, being able to scale those up and down, change those up, change the number, not having to worry about the details of the load balancer configuration, right? So Beanstalk packages a lot of that, and that turns out to be very valuable, for public-facing websites, but equally for folks that need to do big geodata processing on the back end, and might have one application that they use multiple times, all in parallel, right? And so to kind of get that point across, I'm going to go back to the top. You'll see I have one here. So this is an environment called EB_PyR SQS Worker, the same name as I have up on GitHub, right? And so this is an environment of a Beanstalk application I have in play right now, right? And but there's nothing stopping me from going over here and creating a clone of that, where I have, for example, tweaked environment variables, right, to do some other queue, right? Or, I'm in dev mode over here and I'm in production over here. So you can run n number of these with the application at the base of that, okay? And so here, so we'll go back here. You'll see that I'm in a health severe state, right? It tends to go in red really quickly, right? But like I said earlier, there's a lot of stuff that it makes very easy. So, for example, I can tell by looking over here at health, right? Let's see how badly we're doing right now. See if we've got any nodes working. Oh, they're all dead. Oh, there's one. So out of the 10 or so, I have one that probably hasn't been fed bad data yet. That's still chugging along, right? And so what does it take to kind of resuscitate this thing, right? In this case, if I just want to get to market, I need to get this done, right? I just want to look at the data. I'll fix the code later when nobody's bothering me, right? Kind of thing. All it takes is I'm going to go and restart. So you have a couple of choices. You can restart the app servers, which is like a reboot across your fleet of 10 boxes or 10 virtual machines, or you can rebuild from scratch, right? Rebuild would be overkill. All I want to do is reboot these boxes. It'll ask me, sure you want to do this? And I'll hit OK. It'll take a few minutes, but I have 10 server instances that are starting essentially afresh, okay? And so you saw the code. You saw a little bit about Beanstalk. So let's go look and see where the data is. And so, in the code I was talking about grabbing the NEXRAD data from one of our public data sets buckets as a function of an announcement via SNS that's delivered to my Python code as JSON, right? I parse the JSON, look for the bucket name, grab the data, do something to it. Having done something to it, I put it in my own bucket, right? So here is the source data here. And if I go back to root, and look for one of my blue icons here, which are my buckets. And I have, the hardest part is finding it. I have too many buckets. So here's something called EB_PyR worker output. And I've got a bunch of files here. So it could be that I have 136 again. So what's interesting here is, if you remember the source names, it was essentially, this key, which is the station key, and in a date stamp, right? I've taken that off because what I'm after right now is just the current set, right? The newest data. So I've carved that off, and I'm just keeping the station name there. Well, what's interesting about S3 is that it has versioning, right? So you can do something like turn right, and I have the versioning turned on for this bucket. I can show versions, and sure enough, you can see that I've iterated over this file name a bunch of times in the past. So it's not actually deleting anything, right? It's providing me version control. And so what I'm getting at here is, without a lot of complex Python code, I'm just leveraging S3's built-in versioning mechanism, because I'm obviously thinking about time series, right? And so I can leverage the fact that it's doing versioning for me under the hood to be able to write some future code that allows me to, look back into, how, where that tornado went or whatnot, right? At a national scale, though. And I didn't have to write a lot of complex code to get that to work. I'm just leveraging existing feature, right? And so right now, I am in the context of my notebook here in this room, right? I'm looking at this data. I'm using Cloudberry. And I want to switch gears a second. How are we on time? Okay. 4 more minutes of talk time, or am I already into question time? Okay, cool. So I just switched gears here, and now I'm in Virginia. I'm running the Amazon Workspaces client. So I've virtualized my session. I'm running essentially a Windows desktop somewhere in our Virginia region. I don't know what data center, right? But this data now is co-resident with the bucket, the object store that I'm using to output the data, right? And I'm just running QGIS. I'm no QGIS expert here, but I want to go look at some raster data, right? And you'll see that, before I do that, I'm running the same Cloudberry client. So this is a vendor-supplied client to S3. I think the pro version costs all of $39 or something, right? Nicely done, good for Windows users. And on the left-hand side, right now I'm in Virginia, but I'm looking at I'm using the same client. I'm looking at the same bucket, and if I hit the refresh button, I get the most current set of outputs, right? This stuff is being overwritten constantly because I just rebooted Beanstalk. And I'm going to grab these guys, and quickly, see if I can do a select and hit copy. Yes. And yes to all. You can see it did it pretty. These files aren't large, right? But even if they were large, because I'm in the same network, it'd be pretty fast, right? And so now I have them local to my desktop in the cloud, right? I'll switch back to QGIS, and you'll see that the list has changed, right? This is my open data, file open dialog here, and I'm just going to grab a bunch of these guys. We'll see what happens. So there we go. So I'm going to zoom in, roughly the shape of the United States. Right? And so that's it. And so you can see where I'm going with this. So the next stage is I'm using QGIS to see whether this thing works or not, right? And now that I have GeoTIFFs where I'm in familiar territory, right, and in S3, I can leverage, for example, another thing I have on GitHub that would allow me to do real-time tiling of those GeoTIFFs. I just need to update the spatial index, right? And I'm good to go, right? I have to do some artwork around a map layer definition file. But having done that, I just need to have a way to update the spatial index. And I have, going back to everybody now has Doppler radar stations, right? So that's it. Thank you very much. Just as a reminder, we have a session this evening, so if you've got detailed questions, I'm the geospatial geek on the specialist team. Happy to talk about whatever you want to talk about in the mapping realm. Chris actually supports our open data team, so he'll be there too. So thank you very much. Oh, and we have a few minutes for questions. Okay, 5 minutes for questions. So. Please. Yeah, it's already up there. So yeah, I'm sorry, I should have a reference, but if you look for MW Corver, and you could just ask me later too, it's just MWKORVER, that should find it for you. I only have a few things. We have a lot of controls over what we're allowed to post, and so I have a map server GDAL Docker thing up there that allows you, that's built to leverage something we haven't made public yet. It's the USDA NAEP data set. We're working with Mapbox right now to update it with the 2015 data. That's in a bucket. Just you can, if you have a client, you just use AWS-NAEP. You have all of the 1 meter per pixel NAEP data in its original GeoTIFF format. And there's also some derivative in there where I've created some optimized JPEG compressed ones too. So that's also there. But you'll find that if you go look at the GitHub account. Yes?
Is there a reason you went for Beanstalk instead of maybe just trying running on Lambda?
Oh yeah, so the good question, right? So I wish it ran on Lambda, right? But it was mostly, and I think that that's potentially doable, right? But it was mostly the work around getting a GDAL to work appropriately, right? But I know that there's some work being done on that, so that that would be like a simple, even simpler pattern. So that would literally be, there's an event to S3, the topic, you subscribe to it, you have an SQSQ, right? Or you can subscribe directly to Lambda to the topic, right? So there's some interesting architecture there. So there's a bucket. We are giving notification of arrival of bucket. You subscribe to it. You can hang your queue or Lambda or your whatever listener you want basically off of it. Right now we're limiting it to Lambda and SQS because of potential scaling issues on our end, not yours, right? Down the line, you should be able to just hang a Lambda event off that topic, you subscribe to Lambda to the topic, and I would imagine it would be the initial Lambda would be some very simple filter action, and then you probably hang another Lambda off of that is provisioned differently to do the heavier work, like if you're running GDAL or something, right? So like a cascaded thing. Yes.
Would Lambda when you hit that limit, whatever
500 megs for files.
With
yeah.
The GeoTIFFs that you're rendering on, we've actually got Poodle installed on Lambda and running Poodle info, but we just kept hitting. Going down too many
And that's a part of the reason I didn't do it, because I knew about that limit. So I don't have clarity on the roadmap there, but that's one of those things that are going to have to go up over time, because we have too many customers with that problem, right? You can't do things like hang an EBS volume off a Lambda event in real time, right? So I think that eventually go away. The hard part, I'm sure, for the Lambda team is like, well, how much do we need, right? That kind of thing. So.
I have a question about the data set. Currently, I'm paying for Lightning data.
Yeah.
Is that available in here? Am I paying for something?
Lightning data? I don't know what Lightning data is.
Like data where lightning strikes?
Oh, no. So we don't have anything specific to that, but it seems like the Doppler radar would give you a lot of, what you need, right? Maybe not. Okay. Okay. Yeah. Well, so what would that be called? I don't know. Okay. Okay.
But it's not open. Where's that open?
There's some.
I think NOAA has a.
No, they still not public though. Maybe it's the
Oh.
way that's not
Well, let us know what is interesting to you. So it might be part of the public data set in the future. So one of the messages I like to get across, though, so I was talking about NEXRAD, which is one of our object stores, one of our public data sets, right? We in conjunction with like Unidata, help maintain that. Landsat 8 is with Planet Labs, for example, right? But there's nothing stopping you from using S3, and there's a feature with S3 called Requester Pays that allows you to not have economic risk of sharing big geodata or any big data, right? Because somebody wants to pull it out and move it to some other cloud vendor's platform, they pay for data egress. And so that's one of the best, important best practice on our platform. That's something that would be fundamentally impossible to do on-prem, right? You'd have to have a whole complex monetization scheme in order to do that. That is just part of the feature set of S3. It's actually a bucket level feature that takes all of 1 second to check off. And then all of a sudden you can make, if it's a public data set, it's easy, right? You can just say, anybody has read permission against this, but it's not my penny when it goes out, if and only if it goes out the door. But the caveat there is, for example, when we look at our Landsat 8 data, there are folks that pull the data completely out of region. They, clip and ship download routine because they want to look at it on their notebooks or whatnot. But the big users that are using it, in any kind of production, run compute next to the data because that's what makes sense, right? And so there's some small percentage of people that do pull the data out, but as they get to understand that they have access to the full archive in place, then it's easier not to encumber local storage. They move compute to us, right? Just like I did with Beanstalk or Lambda. Right? So. Yeah, and so there is some work there. I don't know what I can announce yet, but thank you very much.